Hi class, this is Dr. Karsten, and today we are doing lesson 17. This is from Module 5, Grade 4, Engage New York Math. And in today's lesson, we are going to continue adding and subtracting fractions, but today, instead of it just being one fraction subtracting another fraction, we are going to be subtracting from 1, or even from a mixed number. So let's jump right in and get started. So here what you can see is I wrote a nice number sentence with start of 1 for us, where I have 1 minus 3/8. And as you can see, the units are not the same. Here I have eighths, and here I have 1 whole. So the first thing that we want to do is we want to rename 1 as eighths. So as you all should know by now and should have down pretty well, when we are renaming this into fractions, if I want to have 8 as my units, and again the units are just the denominator, the number of pieces that make up a whole, the number of parts in a whole, fractional units in a whole, but again this is the units. So if I wanted to rename 1 as eighths, I'm going to rename that as 8/8. And as we all remember, that when our numerator and denominator match, that means that I have 1 whole, because this is telling me that 1 whole is cut up into 8 pieces or divided into 8 equal pieces. This is telling me that I have all 8 of those pieces. Okay, so now it gets pretty easy. We have 8 of those pieces minus 3 of those pieces, because we have 8/8 minus 3/8, and that's going to give me 5/8. So because I have 8 of those pieces minus 3 pieces gives me 5 of those pieces. Okay, so 5/8 is our answer. Now what I would like to do is I want to model that on a number line, and we were doing that a lot yesterday. So let's go ahead and make a number line, and I'm going to have 0, I'm going to have 1, but then remember that what we did was we renamed this 1 as 8/8. So let me go ahead and put my eighths in here to help us out. So I'm going to draw eighths in here as best as I can. So let's check. 1, 2, 3, 4, 5, 6, 7, 8. So sure enough, this is split into 8 pieces. We have all 8 of them. So we're going to start right here at 1, or 8/8. And then we want to subtract 3/8. So what I'm going to do is I'm going to go 1, 2, 3. And I'm going to put that right here. And I'm going to go ahead and model it like this by showing that we subtracted 3/8. When we subtract, we go that way. When we add, we go that way. So we subtracted, and then I need to write what I ended up on, which is 1, 2, 3, 4, 5. 5/8. So we had 8/8 minus the 3/8 got us to the 5/8. So we just modeled it. So let's go ahead and let's do another one just like this. So let me slide this up and let me give us another problem to work on. So this time let's do 1 and let's subtract 2/5 from it. So again, my units are not the same. So what I want to do is I want to turn this 1 into fifths so that the units match. And for this to still be equal to 1, I need to have all 5/5, because if I have all 5 of those fifths, it's just equal to 1. My numerator and denominator match, we're good. So now I can go ahead and say 5/5 minus 2/5. And what do we get? Well, 5 minus 2 is 3/5. So again, this is like a label. It's telling us how big those pieces are. Could we model this? Well, let's first do this again on a number line. So I'm going to go ahead and draw us a number line. We have our 0, we have our 1, and remember 1 in this case is also 5/5. We renamed it. So let me go ahead and draw in our fifths. And now I want to model that we are subtracting 2/5. So I'm going to go 1, 2. So this is where I'm going to end up. And I'm going to go ahead and draw my little arrow showing what we did. And then I do have to here write what we ended up on, which we know is 3/5, but look, I could count up. 1, 2, 3. Okay, so now what I want to do is I want to show this using a number bond. So I'm going to have my 1 right here. And then I want to show the original problem, which was that I had 1, and I knew that I was taking away or subtracting one part of that, which is 2/5, and we were looking for the other part. So I'm going to put x there as the unknown. We often like to use x for that. So if I were to look at it like this, let's write all the possible addition and subtraction sentences that we can for this. So for example, when I have a number bond, one thing I could say is I could say that 2/5 plus x is going to give me 1. So let me write that. 2/5 plus x equals 1. Another addition sentence I could write is x plus 2/5 equals 1. And another sentence I could write, now let's do a subtraction sentence, I could do that 1 minus 2/5 is equal to x. And another one that I could do is I could do 1 minus x is equal to 2/5. So these are all possible number sentences that I could write for this number bond. Well, another way that I could have thought about this, and don't let this confuse you, I just want to model it this one time on here. Another way that we could have thought of this, and I'm going to write a different, I'm going to draw another number line here, and I'm going to go ahead and I'm going to put in our lines and show where everything is. Another way that I could have thought of this was I could have said to myself, let me start at 2/5 here, and I could have said to myself, well, how many more fifths would it take to get up to this 1? So instead of doing 1 and subtracting 2/5, what I could do is I could say, how many more would it take me to go from 2/5 up to 1? And from that I can see it would be 1, 2, 3/5. So we started with 2/5 and we added 3/5 to get to 1. So what we just did was, instead of just thinking of a subtraction, we can think of subtraction as an unknown addend problem and count up. And that's what we just did. So instead of just doing it as subtraction, we could have said, well, if I started at 2/5, how could I, what's that missing addend? 2/5 plus what number, this was our x, is going to get me to 1. And that's another way of looking at this. And that's because all of these are related, right? This is like a fact family. So I just wanted to kind of point this out once. I think probably most of us are going to do it this way, where we're going to subtract, but you should always know that you can count up. I was just doing that with my daughter earlier today. Okay, so let's do just one more problem really quickly. Let's do, let me move this up a little bit, and let's go ahead and let's do 1 minus 7/12. Now if I'm looking at 7/12, let me just say right off the bat that for that one it might be easier to count up. So I could count up from 7/12, and remember, we're going to make this 1 is going to become 12/12, because 1 whole would be 12/12. If it's divided in 12 pieces and I have all 12, makes 1 whole. And I'm still subtracting that 7/12, but instead I could think, let me count up from 7/12 to 12/12. So then I could just go, well, 7 to 8 is, so we could say 8/12, 9/12, 10/12, 11/12, 12/12, and I have 5. So let's try the other way. Let's say 12 minus 7. Well, that is also going to be 5/12. And I could do a quick number line, and I'm just going to do the subtraction one really quick. Oh my goodness, do I really want to have to draw in 12s? I guess. 0, 1. Oh my goodness, this is going to be a lot of lines. Okay, so this is 12/12. And again, I could subtract 7/12. 1, 2, 3, 4, 5, 6, 7. the other option, and then I get to 5/12, or the other option would have been, I'm going to do the same thing. Sorry, just takes a second to do all those 12ths. The other option would be to start at 7/12, 1, 2, 3, 4, 5, 6, 7, and then to see how many more 12ths to get to 1. 1, 2, 3, 4, 5. Okay, so if that's going to confuse you doing it this way, then don't. And in fact, just to make sure that we don't get super confused, you could have just stopped here. You could have just done the subtraction. So to make sure that we don't get confused over that anymore today, I'm going to stick to the subtraction because I really don't want that to confuse you too much. And so let's move on. Let's try problems where we're subtracting a fraction from a number between 1 and 2. So basically, we're going to be using mixed numbers at this point. So let's say that I have 1 1/5 minus 2/5. So before, what we were doing is we were taking that whole, that 1, and we were turning it into units that matched our other fractions. And we can do that again since we have fifths here. We can take this 1 and we can turn that into 5/5. So now what I know is that I have 5/5, right? And we're just using a number bond. And I also have this 1/5. So we're decomposing 1 1/5 into its 1, its 5/5, and its 1/5. And now what we can do is we can combine these together into 6/5. All I did was I added 5/5 and 1/5 is 6/5. So we just took 1 1/5 and we turned it into 6/5. That 1 was equal to 5/5, but it still had this extra fifth on there. And then we combined them to make 6/5. So now I can bring this down here and say 6/5 minus 2/5. Well, 6 pieces minus 2 pieces gives me 4/5, or 4 pieces. Now let me do this with a tape diagram really quickly. So again, we're going to have fifths, but we have more than one whole. So I'm going to go ahead and draw this out. These are all fifths. Now, if I don't tell you what one whole is, you would think that these are actually sixths, but they're not, because I'm going to show you that 5 of them make up one whole. You always have to bracket it off so that your people, your audience, can tell what you're doing. Okay, so I have 1, 2, 3, 4, 5, 6 fifths. So that's this part right here. And now we need to subtract 2 of those. And I'm just going to go ahead and X those 2 off. And then that leaves me with 1, 2, 3, 4 fifths, which is exactly what we got down here. So 6 fifths minus 2 fifths. There is another way of modeling it. I am going to show it to you one time, and I am not going to show it to you again tonight because I think that it's going to mess you up, but I do want to show it to you. So another way that we could have thought of this was for me to again draw my 6 fifths. Now if this is going to confuse you, just cover your ears until I finish this little box and then come back afterwards. Okay, so another way that I could have thought of this was to again show my 5 fifths, so show that that's one whole, but then instead of crossing off from the end, I could have taken away, subtracted the 2 fifths from the 5 fifths, and then combined my 3 fifths and my 1 fifth. Again, this is probably going to not work for most of you, but it is part of this lesson, and it is something that I do want to show once. So what I did was I took this 5 fifths, the one whole, and I'm going to subtract out those 2 fifths to get 3 fifths. That's all that's happening here. See how I have 3 fifths left? And then you have to take these 3 fifths, what you just got, and add this missing 1 fifth, or that 1 fifth on, and you get 4 fifths. Now again, I think that this is going to mess you guys up, and I think we're going to stick with this. So let's do a couple more problems or examples like this, just to make sure that it is not going to mess you guys up. So let's go ahead and do another example like that, and then we can do some from the problem set. So let's do 1 1/4, or 1 1/4, and let's subtract 3/4 from that. So again, the first thing I have to do is I need to have like units here. Right now I have 1 1/4 and 3/4. Well, I can't pull 3/4 out of that. I have to do something with this to make it work. And what I have to do is I have to combine, or I have to get like units. So I'm going to take this 1 and I'm going to turn it into 4/4. I want it to be fourths because there are fourths all over the place. It'll make it easier to work with. And since it's 1 whole, it has to be 4/4. Well, I can't forget about this 1/4, right? So I have 4/4 and 1/4. And 4/4 plus 1/4 is just 5/4. So that's what we're starting with, is 5/4. But now you don't want to forget what you're subtracting, which is 3/4. So again, I took my 1 from my 1 1/4, and I turned it into 4/4. I brought down my 1/4, and then I recombined them. Here they're all together. We put them all together here as fourths, so it's 5/4. So we have 5/4 minus 3/4. Well, that's 5 pieces minus 3 pieces is 2 pieces. How big are your pieces? They're fourths. So let's go ahead and let's model this with a tape diagram, because I think that's always helpful. So let's first do it like this, because I think this is going to be helpful if I do it like this. Let's first model the 1 whole, right? Or let's show it. This was 1 whole, and then we had a 4 added onto it. So this is 1 whole and a 4th. Then what we did was we took that 1 whole and we said, well, if we have fourths all over, let's turn this into a fourths also. And so we decomposed it into fourths. So that's what we did. We showed that 1 whole can be shown as 4/4, which means we have 1, 2, 3, 4, 5/4, because we started with 1 1/4. So we have 5/4, and then we have to subtract 3/4. 1, 2, 3. So those are gone. And now we are left with 2/4, which is exactly what we got. And again, I could show the math. I could show that 5/4 minus 3/4 is equal to 2/4. Or 1 1/4 minus 3/4 is 2/4. Okay, I think I've done enough modeling for this. Let's jump into the problem set, and let's do a few problems from the problem set. If I can figure out where on my desk I have that. Here we go. So let's jump into these questions. I'm just going to move this so it doesn't shine through the paper. Okay. So for question 1, it says use the following fractions to write 2 subtraction and 2 addition number sentences. So what do you guys think we're going to be doing with that? Do you see any relationships between those? Could those be fact families for us? Well, I can see that I have 8/5 and 2/5 and 10/5, and I definitely see that 8 plus 2 is 10. So that's where I'm going to start. Remember, these are like labels. It would be like saying 8 apples plus 2 apples is 10 apples, only instead of apples, we have fifths. So let's go ahead and write that. 8/5 plus 2/5 equals 10/5. And now I'm going to do the related addition sentence, where I just have to flip these two around. Commutative property. 2/5 plus 8/5 equals 10/5. And now let's write the subtraction fact. 10/5 minus, let's do 2/5 first, just because that way I'm just going straight backwards, is equal to 8/5. And now we can do the last one, which is that 10/5 minus the 8/5 is equal to the 2/5. Okay, you guys can try 1B on your own. Let's jump into problem 2. Sorry about all the noise. Solve, it says solve, model each subtraction problem with a number line and solve by both counting up and subtracting. And it says part A has been completed for you. So So my concern is that if I do both counting up and subtracting, I think that we're going to throw you guys off big time. So what I want to stick with is that I'm going to just do subtraction on here instead of the counting up. Sometimes it would be easier to count up, for example, on this one. But I really want to focus on doing it one way for you guys. You may do it either way, whatever you're the most comfortable with. So let's start with this one, where we have 1 minus 8/10. So again, I need to take that 1 and I need to turn it into tenths. I want to have common units going on here. So if I want to take that 1 and turn it into tenths, I need to have 10 tenths. So 10 tenths minus 8 tenths. So 10 minus 8, 10 pieces minus 8 pieces, gives me 2 pieces, and they're all tenths. So now let's go ahead and let's do that number line and see how that goes. So we have to do tenths. That's going to be a lot of pieces. So I'm going to need a kind of long number line here. And I might be going off camera. I'll move it if I have to. Slightly off camera. Okay. So let me go ahead and see if I can draw this for us. We have 0. We have 1. Oh, 1. I was thinking tenths, sorry. 1. And then let me go ahead and try and make all of our even tenths. They're okay. Not perfect, but that's okay. Okay, so we have 10 tenths. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, this is 1 whole, or another way to write it would be 10 tenths. Now I have to subtract 8 tenths. Now if you were counting up, you would start here and you'd count up to the 2 tenths, but I'm just going to stick with subtracting 8 tenths. Let's go ahead. 1, 2, 3, 4, 5, 6, 7, 8. And now I want to show what I just did, which was to subtract 8 tenths. And let's see what we end up with. 1, 2. 2 tenths, which is exactly what we got there. Let's do another one. Let's do, oh wow, so, sorry, I'm just looking at something. Let's go ahead and let's do D together. So let's try D. So again, I have eighths here and I have 1 whole there, so I want to turn that 1 whole into eighths. And if I do that, I'm going to have 8 eighths minus 5 eighths. Okay, so 8 eighths minus 5 eighths, 8 pieces minus 5 pieces, gives me 3 pieces, and the size of those pieces is eighths. So now let's model that on a number line. So I'm going to have 0, I'm going to have 1, which is really just 8 eighths, and then I'm going to draw in all my eighths. So let's check. 1, 2, 3, 4, 5, 6, 7, 8. We're starting at 8 eighths. I'm going to subtract 5. 1. We're counting our hops, remember that. 1, 2, 3, 4, 5. And now I have to show what I just did. I subtracted 5 eighths. And I ended up at 1, 2, 3, 3 eighths. And there you have it. Okay. You are going to try C on your own, but before I send you off to do E on your own, let's take a look at F. Because now we have what we were looking at in the second set of problems that we were doing in the examples, which is that we have 1 and a fifth. So the first thing that I have to do is I have to decompose this into its 1 and its 1/5. But in addition to decomposing this into 1, I also want to have the common units of fifths. So instead of writing 1 and putting the 1/5 here, which I can just bring that down, this one has to be 5 fifths. And then I can put those back together. So I'm going to have 5 fifths plus 1/5 is 6 fifths. And that's what I'm going to be working on. That's what I'm going to be working with. So now what I have is I have 6 fifths minus 3 fifths. And I'm going to rewrite it this time just to keep it, kind of neat. 6 fifths minus 3 fifths is equal to 6 minus 3 is 3 fifths. So now what we want to do is we can, do they want us to use a type diagram? I don't think so. It says that we want to do it with a number line again. So let's go ahead and let's draw our 6/5 on a number line this time. So I know that this was a fraction greater than 1, so I'm definitely going to have to go over the 1. So I'm going to put my 2 here. And now I need to turn these all into fifths. I need to show all my fifths in there. I need to draw them in, model them. So let's check 1, 2, 3, 4, 5, and let's do the same thing over here. 1, 2, 3, 4, 5. And now I need to show that I'm starting at 6/5, which is the same thing as 1 and a fifth. So watch. 1 and a fifth, which is the same thing as 1, 2, 3, 4, 5, 6/5. And now we're subtracting 3/5 from that. So let's go back. We're going that way. 1, 2, 3. We need to model that we just subtracted 3/5. And now let's see what we're at. 1, 2, 3. I hope that everyone is noticing how I'm hopping. Every time I want to count, I can't say 1 here. I have to hop and say 1. So 1, 2, 3/5. Okay, so we did this and it looks great. And we had a chance to show that it's 1 and a fifth is the same thing as 6/5. We subtracted 3/5 and we ended up with 3/5. So as part of your independent work, you are going to do C and E on your own. So let's go ahead and let's take a look at the next page and see what we have going on. And just kind of even all these papers out. Okay, so now it is telling us, oh, my throat's a little scratchy, sorry. Drink something. Okay, so it says find the difference in 2 ways. Use number bonds to decompose the total. And it says part A has been completed for you. So what they want us to do here is to first go ahead and decompose the whole. So that's what they're saying, is to decompose the whole. They're saying take that 1 and turn it into 5/5 in this example. That's what you're doing. And then here, basically, you're just working with your fact families to show what you're doing. So let me show you what they did here. They took the 1 and 2/5, and then they subtracted 4/5. So we decomposed the 1 into 5/5, and then we had 2/5. And what they did was here, they took this and they showed it to you up here, and they added it. Because I don't want you to think that this is something else. I really want to be clear about this. So they took this, they moved it up here, and we can see 5/5 plus 2/5 is 7/5. That's just this, in case you look at it later. And then they showed the next step, which is to take this 7/5 and subtract 4/5 from it to get 3/5. I didn't want you guys to look at this and think that these were fact families, because they're not. They definitely are not. You can see that these are not the same numbers being used. Now, the other thing, this is that other way that they did it. We're not going to do that unless it's something you really, really want to do. We're just going to stick with doing it this way. So I'm going to model 2 of them for you and let you do the other 2 on your own, because I think that this is really confusing the way they've shown it, and I'm worried about you guys doing this on your own and getting confused. So let's do a couple problems together. So again, the first thing we have to do is we have to decompose this 1. So let me slide it up so we don't have all that mess above us. So since I'm working with 6th, I need to turn that 1 into 6. And how many 6ths am I going to have? 6/6. But don't forget that you have your 3/6. And then what you have to do is you have to combine those again, because you had 1 and 3/6. So 6/6 plus 3/6 is 9/6. And now what we can do is we can take this 9/6, and I'm going to go ahead and write that up here. I don't mind doing that. And I want to subtract 4/6 from it. And when I do that, I have 9 of those pieces minus 4 of those pieces, and that leaves me with 5/6. So again, 9 minus 4 is 5, and all the parts the units are 6. Okay, I hope this is making a little bit more sense. So this is how easy it's going to be. If you want to then model it, you are welcome to model it. I'm going to do one more for you, and you really have very little work that you're going to have to do on your own. So let's take a look at this. So the first thing I need to do is I need to decompose that 1 into 8ths. So I'm going to have 8/8. And then I can't lose that 6/8, don't forget it. And I want to recombine this now. So it's going from 1 6/8. Now it's going to be 8 plus 6 is 14/8. And that's what they're just doing when they were doing the 2 different steps up there. But we're doing it down here. We're modeling it a little differently. So now I want to take that 14/8, and I still want to subtract 7/8 from it. I want to do 14/8 minus 7/8. That's equal to 7/8. Okay, I hope that this is making more sense now and that we're kind of keeping it really simple. So you have to decompose your 1, then you have to recombine all of this from your mixed number into a single fraction, which is 14/8 in this case, and then you just have to do the sentence that they have up there for you. So I think this is not too bad. You're welcome to still model it with a diagram, a tape diagram, or a number line. It's up to you. Okay, so I think that is good. I think we're good for tonight. Another relatively short lesson, which I'm pretty happy about. So what you guys are going to do is you are going to finish out the rest of the problem set on your own. So you are going to do 1B, you are going to do 2C, 2E, and then you are going to do 3D and 3E. So it's really not bad. All right, so class, I hope that made sense, and I will see you in the morning in our Google Classroom. Have a great night, everyone. Bye.